Hi guys. Okay, let's look at the solubility of ionic compounds, and it is governed by the solubility rules. And as you can see on the screen, there are certain rules when the compounds, which kind of ionic compounds are going to be soluble in water and which kind of compounds are not going to be soluble in water, and what are the exceptions. So first of all, what is solubility? Solubility is when an ionic compound ionizes in water, then it forms a clear solution. Why? Because all the ions get solubilized, or hydration is a term for them. So that is how you cannot see the ions. So you can see maybe the little color which is associated with the ions, but that's about it. But it is still going to be a clear solution, and the light is going to pass through that solution. So that means that that particular ionic compound is soluble in water. What about the insoluble compounds? Insoluble compounds remain suspended in solids, and we call them as precipitates. Okay, so either you're going to see a solid sitting at the bottom, or you're going to see a solid floating on the top, or you're going to see the solid which is suspended in the test tube. Okay, so what kind of compounds are insoluble in water and what kind of compounds are soluble in water? Let's look at that. So all the group 1A elements, that such as lithium, sodium, potassium, rubidium, and cesium, they are going to dissolve in water. That means they will ionize in water. And when any time these ions are connected with, no matter what, any kind of an ion, it's always going to be soluble. Similarly, whenever ammonia attaches to any of the anions, it is going to be soluble in water. Same story with the nitrates, chlorates, bicarbonates, and acetates. Whenever they combine with any of the cations, soluble in water. Now let's look at the halides, such as the chlorides, bromide, and iodides. Yes, they are also going to be soluble in water, except silver chloride, AgCl, silver bromide, AgBr, silver iodide, AgI. That's going to be insoluble. Lead has got two oxidation states, or 2+ charges, and two charges. One is lead +2 and lead +4. Lead +2, when that combines with the chloride, bromide, or iodide, that lead compound is going to be insoluble. But if lead 4 combines with chlorine, bromine, and iodide, any one of these these anions, it is going to be soluble. So keep that charge in mind for lead. Okay. Similarly, look at the sulfates. Or anytime sulfate attaches to any of the cations, the compound, that ionic compound, is going to be soluble, except silver sulfate, lead sulfate, calcium sulfate, barium sulfate, and strontium sulfate. Okay, so these are the exceptions you need to keep in mind. Now let's look at the insoluble compounds which form solids in the aqueous medium, that is water. Okay, so that's all the carbonates. Anytime carbonate is attached, chromate, phosphate, sulfide, and hydroxide, anytime they attach to any of the cations, they are always going to be insoluble, except when they attach to all the elements that are in group 1A and ammonium. And in the case of hydroxides, when barium combines with a hydroxide, it forms BaOH whole twice, which is actually going to be soluble in water. Okay, so you're going to show it as AQ. So those species that are soluble in water, we show it in the subscript as AQ. And those species that are insoluble in water, we represent them as S. Now, S means solid and not soluble. So keep that in mind. Okay, now let's look at some of the examples here. So the kind of questions that can be asked to you, you will be given in chemistry just the name, and you need to write the formula, and you need to identify the solubility. Okay, so here is your name of the compound, ammonium carbonate. So write the formula of that compound first. Ammonium, and again, these are some certain things that you just have to memorize. So here is your ammonium +1 charge, and then comes the carbonate. Carbonate is CO3 with -2 charge. Okay, so when you write the formula, you basically crisscross these charges. So this 1 charge comes here, but we never write 1, but anything that is above 1, we write it. And now the formula is NH4, because we brought 2 from top of carbonate. So this is going to be NH4 whole twice and CO3, because we brought down 1 from top of ammonium. So for 1, we never write the subscript 1. So we leave it as it is. That is why we didn't put it in the brackets also. So this compound, ammonium carbonate, in other words, it also means since carbonate has 2 negative charges, it is going to need 2 ammoniums to neutralize those negative charges, and ammonium has only +1 charge. That is why you need 2 charges. Okay, so that's why. Now question is about the solubility, whether it's soluble in water or not. So yes, all carbonates are insoluble in water. We looked at it. All carbonates are insoluble in water, but because carbonate is attached to ammonium, that is why this is going to dissolve in water, and we are going to show it as AQ. Okay, let's look at sodium sulfate. Sodium sulfate is formula sodium, and sodium is in group 1A, so +1 charge. Sulfate is SO4, charge is -2. Again, you need to memorize this. Okay, so -2 charge on sulfate and +1 charge on sodium. When they crisscross, these charges crisscross, 1 comes at the base of sulfate and -2. So we leave the minus charge, 2 comes at the base of sodium. So now the formula becomes Na2SO4. So this means that in order to neutralize 2 negative charges on sulfate, we would need 2 sodiums. Okay. Now again, all sulfates are soluble in water, and sodium is a group 1A element. So this is going to be soluble in water, and we represent it as AQ. Okay. So this is soluble. Ammonium carbonate and sodium sulfate is soluble. Then comes iron chloride. Now iron chloride, iron in its +3 state, and there's iron in +2 state also. But so pay attention to this number right here. So here is your iron, Fe +3, and this is chlorine, and chlorine will always have -1 charge. So once again, you're going to do the crisscrossing. This 1 comes at the base of iron and 3 comes at the base of chlorine. And what do you get? You get FeCl3. So remember, anytime you're bringing down 1, you never write it. You just leave it. It means 1 iron. So this means that for iron with +3 charges, you would need 3 chlorines to neutralize those charges, and each of the chlorine is carrying just 1 charge, -1 charge. Okay, so now the solubility. So all chlorides are soluble in water, and iron, if you look at it here, all chlorides are soluble in water, and iron is not an exception. Therefore, this compound is also going to be soluble in water, and we're going to write down it as aqueous. And we're going to, so this is soluble in water. Okay, now again, something to keep in mind about solubility: it can change, it varies, so it is a very it's a very dynamic phenomena. So it depends how much of it is. Remember, it can form a soluble saturated solution, unsaturated solution, supersaturated solution. So those things about solubility. Okay, so then comes barium hydroxide. Now barium is in group 2A, so +2 charge. Hydroxide, polyatomic ion, it has got 1 negative charge. So for the most part, you should know the formulas and the charges of the the cations as well as the anions, and that also includes the polyatomic ions. So now let's look at this. This 2 comes at the base of OH, and this -1 or just 1 comes at the base of barium, and now you are having this formula BaOH whole twice. Okay, and so yes, all hydroxides are going to be insoluble except the cations coming from group 1A. Ammonium, this is going to be plus charge on ammonium, and when barium is combining with a hydroxide. So those species are going to be soluble in water, and we are going to show this as AQ, and this is soluble. Okay, soluble means it's going to ionize to some extent in water. Now let's look at lead phosphate. Now this is lead with +4 charge. So Pb is the symbol for lead. +4 charge is the charge on lead, and phosphate is PO4. PO4 is 3 negative. Okay, so now when you crisscross, you are going to get 4 at the base of phosphate and 3 at the base of lead. So what is the formula now? The formula looks like Pb 3 parenthesis or brackets, PO4 whole, PO4 whole 4. Okay, so this is going to be the formula for lead phosphate. So what is the solubility? Now here's this, according to the solubility rules, phosphate is insoluble. Anytime phosphate attaches to anything, it is always going to be insoluble. And lead is not in the exception category. In other words, lead is not present in group 1A. Lead is not ammonium, obviously. So this is going to be existing as a solid or a precipitate. So this is insoluble in water. Okay, let's look at the last example, zinc nitrate. Now zinc is in the D block and it will have +2 charge, nitrate NO3, and this will have a -1 charge. So what are you going to do here? You're going to crisscross to write the formula now. So for every zinc, you would need 2 nitrates. That's what it means. And when you crisscross, you get the formula which looks like, Zn parenthesis NO3 whole twice. Okay, and so this is zinc nitrate, and nitrates, all nitrates are soluble in water. So this is AQ, soluble. Okay, so this way you will be, you need to memorize the solubility table. Best is to memorize it, but in case you are, you feel that you won't be able to, or you will remember, you will forget, let's say on the exam or something, and if it is allowed, you can create a little, your own little notes or the note cards, and that will help you to remember, and keep thinking about it. And there is a way of learning chemistry, which, I'm going to talk later, but for now, I hope this was easy, and thank you for watching.